For my chemistry project, I decided to make chocolate chip cookies. For this recipe, we would need 3 cups of flour, 1 cup of sugar, 1 cup of brown sugar, 1 cup of chocolate chips, 1 teaspoon of salt, 2 eggs, 1 cup of softened butter, half a teaspoon of baking powder, 1 teaspoon of baking soda, and 2 teaspoons of vanilla extract. So here, we will need to preheat the oven to 375 Kelvin. This is so that when the cookie dough is done, the air inside the oven will have around the same temperature, as it takes time for heat to spread. Normally, to get softened butter, you would have to wait until the butter is at room temperature. However, I can show you a much quicker way to get softened butter. The reason the butter gets soft when it is at room temperature is because the air is transferring heat to the butter, thus adding energy to the molecules and breaking some intermolecular bonds. What I did here, as I may or may not have forgotten to leave the butter out at room temperature, is cut the butter up into smaller pieces. Because of the greater surface area, more heat can be transferred to the butter as air molecules collide with more of the butter. You can also put the butter between 2 pieces of baking paper and roll it out with a rolling pin. It basically does the same thing as it adds more surface area to the butter. The next step is to mix together the flour, baking soda, baking powder, and salt. Then, in a separate bowl, I creamed the softened butter with the sugars. The reason we use softened butter is so we can trap air bubbles, which can then expand during the baking process of the cookie. This works because of Charles' law, where if temperature goes up, volume also goes up. If the butter is too cold, the molecules of butter would not have enough heat or energy to split apart, thus resisting the expansion of air. If the butter is too hot, air pockets would be close to non-existent as the intermolecular bonds of the butter are too weak to contain the air, leading to a lot of spreading. The reason we are creaming together the butter with the sugar is because sugar makes it easier to aerate the butter as these tiny crystals dig holes into the butter as it is being mixed, which forms more air pockets. The next step is to add in the eggs and the vanilla extract, and mixing well. The eggs are what I would like to call a provider. It gives the water for gluten development and steam production, gives the egg yolk, which has the molecule that can emulsify the fat with water, and gives proteins, which provides structure to the cookie. The molecule that can emulsify water and fat is called lecithin. It works by dissolving one side of the molecule in water while the other side dissolves in oil, thus emulsifying the butter and egg whites. The way the proteins contribute to structure is by a process called denaturation. This is where a protein is changed at a molecular level. For the cookies, the proteins are heated, causing weak bonds to break. The denatured proteins then form a complex structure by creating stronger bonds and then solidifying, contributing to the structure of the cookie. When the eggs and vanilla extract have been thoroughly mixed, add in all the dry ingredients. Then, mix until homogeneous. This is where gluten is made. Gluten is the main thing that provides the structure of the cookie, which is made from glutenin, gliadin, and water. These 3 things end up making gluten strands by the use of hydrogen bonding, which can attach to other gluten strands during mixing to make a much tougher and chewier cookie. The flour can also thicken the dough of the cookie by the use of gelatinization. This is where the water and the heat interact with the starch in the flour, which can cause the starch to break intermolecular forces and have a hydrogen bond with the water, keeping the dough together. Salt also affects the gluten, as it reacts with its proteins and increases the bond strengths between the gluten strands. Gluten molecules naturally have a slight positive charge, which would make them repel from each other. However, when you add salt, which dissolves into sodium and chloride, some of the chloride ions will bond with the gluten, neutralizing the positive charge. This means that by adding more flour, you would get a much denser and tougher cookie. This is also where the butter and sugar can affect the gluten. Fat affects gluten production by coating the present gluten strands, preventing them from bonding from other gluten strands in water. Sugar works in a similar way. As sugar is extremely polar, it can easily bond with water, which prevents the production of gluten. After you finish mixing, your dough should look a little bit like this. At this point, you would want to add in the chocolate chips, which are primarily for flavor. After the chocolate chips are just about evenly spread out, the dough is rolled into balls and placed onto a tray with baking paper on top. Then place the tray into the oven and wait for about 8 to 10 minutes, or until the cookies are slightly browned. During the process of baking, the cookie dough undergoes a transformation. Like I previously mentioned, this is where the proteins in the eggs unfurl and make a complex web. This is also where the baking soda and baking powder becomes important. These two ingredients are both leavens, which means they produce gas to fluff up the cookie. The difference between baking soda and baking powder is that baking soda needs to react with an acidic ingredient, like molasses in brown sugar, while baking powder already has the acidic ingredient. These two leavens both produce water and CO2. The sugar also reacts during this baking process with caramelization and Maillard reaction. Both of these reactions produce similar results. The sugar in both reactions break down and produce a varying amount of chemicals which change the way the cookie tastes. They also both produce the brown look of the cookie. The main difference between Maillard reaction and caramelization is that Maillard reaction requires an amino acid, or a protein, while the caramelization does not. This means that in Maillard reaction, the sugar reacts with a protein to make a polymerized protein and brown pigments, while in caramelization, the sugar is broken down, giving the taste of caramel. Here you can see a shot of an uncooked cookie out of the oven. This is just because the plastic on this band started to melt, so I took the chance to explain how cookies spread by the use of butter. As heat is continuously being applied to the cookie, the butter's intermolecular bonds are being broken, thereby spreading the cookie. The reason the cookie did not spread too much is because of the gluten and the complex web of proteins, which are holding everything together. After 8 to 10 minutes, your cookies should come out as a bit soft and may seem undercooked. However, after cooling down the cookies, they should firm up, as I showed in this scene. The reason they firmed up is because the water, which is being turned into steam, is escaping, thus making the cookies hard and crumbly. This is the end of my chemistry project. I hope I did well and didn't miss anything vital. Maybe I should have put in a picture of Darth Vader to bribe Dr. Dunn or something, but I didn't do that, so I guess I can only hope. Regardless, I'm going to have a bunch of cookies to consume. As you can see on the screen, I've made a bit too much, so, well, yeah, cookies.